AZLAN MA presents The Influence of Diet and Nutrition on Benign Prostatic Hyperplasia, Wednesday, 29 July 2026.
Part 1. Understanding benign prostatic hyperplasia and the central role of chronic inflammation. Benign prostatic hyperplasia, BPH, is one of the most common disorders affecting aging men. It is characterized by the non-cancerous enlargement of the prostate gland, a walnut-sized organ situated immediately below the urinary bladder and surrounding the first part of the urethra. Although the condition is benign and unrelated to prostate cancer, it can significantly impair quality of life by interfering with normal urinary function. BPH becomes increasingly prevalent with advancing age. Histological evidence of prostatic enlargement is present in approximately half of men by the age of 50, rising to around 70% by the age of 60, and affecting as many as 80 to 90% of men over the age of 80. Nevertheless, not every enlarged prostate causes symptoms. Some men have markedly enlarged glands yet experience little discomfort, whereas others develop troublesome urinary symptoms despite only modest enlargement. The symptoms associated with BPH are collectively known as lower urinary tract symptoms, LUTS. These include urinary frequency, urgency, nocturia, the need to pass urine repeatedly during the night, hesitancy, a weak urinary stream, intermittent flow, prolonged voiding, straining to urinate, and the sensation of incomplete bladder emptying. In more advanced cases, BPH may lead to acute urinary retention, recurrent urinary tract infections, bladder stones, bladder damage, and, occasionally, impaired kidney function. For many decades, BPH was viewed primarily as an inevitable consequence of aging and hormonal changes, particularly the lifelong action of dihydrotestosterone, DHT, a potent androgen produced from testosterone by the enzyme 5-alpha reductase. While DHT undoubtedly plays an important role in maintaining prostate growth throughout adult life, this explanation alone has proved insufficient. Modern research has fundamentally changed our understanding of the disease. Rather than being simply an age-related hormonal disorder, BPH is now increasingly recognized as a chronic inflammatory disease characterized by persistent immune activation, oxidative stress, and abnormal tissue remodeling. Hormonal changes remain important, but they interact closely with inflammation, metabolic dysfunction, and the aging process itself. This revised understanding has profound implications. It suggests that BPH is not merely an unavoidable consequence of getting older, but a condition whose progression may be influenced by modifiable lifestyle factors, particularly diet, body weight, physical activity, and metabolic health. Hyperplasia is not the same as inflammation. The term hyperplasia refers to an increase in the number of cells within a tissue, resulting in enlargement of the affected organ. In BPH, both the epithelial cells that line the prostatic glands and the surrounding stromal cells proliferate, producing the characteristic nodules that gradually enlarge the prostate. Inflammation, by contrast, is the body's natural defense response to injury, infection, or other harmful stimuli. Acute inflammation is generally beneficial, helping eliminate pathogens and repair damaged tissue. Chronic inflammation, however, is a very different process. When inflammatory responses fail to resolve, immune cells continue to infiltrate tissues, releasing cytokines, chemokines, and growth factors that perpetuate tissue injury and abnormal repair. Hyperplasia and inflammation are therefore distinct biological processes, but in the prostate they are intimately connected. Chronic inflammation does not merely accompany BPH. It appears to drive many of the cellular changes responsible for prostatic enlargement. Today, many researchers regard chronic inflammation as one of the principal engines of BPH progression. Chronic inflammation, a driver of BPH. Microscopic examination of prostate tissue removed during surgery consistently demonstrates inflammatory infiltrates in a remarkably high proportion of men with BPH. Depending on the study, inflammatory cells are present in approximately 40 to 80% of biopsy and surgical specimens, with even higher frequencies reported in men with larger prostates or more severe urinary symptoms. The inflammatory infiltrate consists predominantly of T lymphocytes and macrophages, together with B lymphocytes, mast cells, and other immune cells. Rather than representing a transient immune response, these cells often persist within the prostate for years, producing a state of chronic, low-grade inflammation. Clinical studies have repeatedly shown that men with histological evidence of chronic prostatic inflammation tend to have larger prostate volumes, higher International Prostate Symptom Scores (IPSS), greater urinary obstruction, faster progression of symptoms, increased risk of acute urinary retention, and a higher likelihood of eventually requiring surgery. These observations strongly suggest that inflammation is not simply a consequence of prostate enlargement, but contributes directly to disease progression. The self-perpetuating cycle of inflammation. Current evidence indicates that BPH develops through a vicious cycle of chronic injury and abnormal wound healing. Various insults, including metabolic abnormalities, hormonal changes, urinary reflux into the prostatic ducts, oxidative stress, infection, and age-related cellular damage, injure prostatic tissue. In response, immune cells migrate into the gland and initiate an inflammatory reaction. These immune cells release numerous signaling molecules, including interleukin-6, IL-6, interleukin-8, IL-8, interleukin-17, IL-17, tumor necrosis factor alpha, TNF-alpha, and interferon gamma, IFN-gamma. Growth factors such as transforming growth factor beta, TGF-beta, are also released. Together, these inflammatory mediators stimulate both stromal and epithelial cell proliferation while simultaneously suppressing programmed cell death, apoptosis. Fibroblasts become activated and deposit increasing amounts of collagen and extracellular matrix, producing fibrosis and tissue stiffening. As the enlarged tissue becomes increasingly fibrotic, local blood flow may be compromised, creating areas of relative oxygen deprivation. This hypoxic environment generates reactive oxygen species that further amplify inflammation and oxidative stress. The result is a self-reinforcing cycle in which inflammation promotes tissue growth promotes further inflammation, and both processes progressively enlarge the prostate. Aging, cellular senescence, and the aging prostate. Age remains the strongest risk factor for BPH, but aging itself is no longer regarded as merely the passive passage of time. As cells age, many enter a state known as cellular senescence. Senescent cells no longer divide normally, yet they remain metabolically active. Rather than becoming biologically silent, they begin secreting a complex mixture of inflammatory cytokines, growth factors, proteolytic enzymes, and other signaling molecules. This phenomenon is known as the senescence-associated secretory phenotype, SASP. SASP transforms senescent cells into chronic sources of inflammation. Instead of supporting tissue repair, they continually stimulate neighboring cells to proliferate, while simultaneously attracting additional immune cells into the prostate. Consequently, aging itself becomes a driver of chronic inflammation. This helps explain why the prostate continues to enlarge in many older men even in the absence of overt infection or obvious injury. The concept of inflammaging, the gradual accumulation of chronic, low-grade inflammation during aging, is now regarded as a central feature of many age-related diseases, including atherosclerosis, type 2 diabetes, Alzheimer's disease, and BPH. Why diet matters? Understanding BPH as a chronic inflammatory disease fundamentally changes how we think about prevention. Inflammation is strongly influenced by diet. Foods rich in refined carbohydrates, added sugars, processed meats, saturated fats, and ultra-processed ingredients promote oxidative stress and inflammatory signaling throughout the body. In contrast, diets rich in vegetables, fruits, legumes, whole grains, herbs, spices, and other plant foods provide antioxidants, fiber, and thousands of phytochemicals that help dampen inflammatory pathways. These dietary patterns also influence obesity, insulin resistance, lipid metabolism, blood pressure, gut microbiota, and hormonal regulation, all of which are increasingly recognized as important contributors to prostate enlargement. Rather than focusing on a single nutrient or so-called superfood, modern nutritional science increasingly emphasizes overall dietary patterns. The cumulative effects of thousands of meals consumed over decades appear to shape the inflammatory environment in which the prostate ages. The encouraging implication is that while aging itself cannot be prevented, many of the biological processes that accelerate prostate enlargement may be modifiable. Nutrition therefore represents one of the most promising avenues for reducing the risk of BPH or slowing its progression. In the next section, we shall examine the growing body of scientific evidence linking specific dietary patterns, foods, and nutrients to the development and progression of benign prostatic hyperplasia. Part 2. How diet shapes prostate health. The recognition that benign prostatic hyperplasia is, at least in part, a chronic inflammatory disease has profound implications for prevention and management. If chronic inflammation helps drive prostate enlargement, then reducing inflammatory stimuli should, in theory, reduce the risk of developing BPH or slow its progression. An expanding body of epidemiological, clinical, and experimental research suggests that this is indeed the case. Although genetics and aging remain important determinants of prostate health, diet is one of the most powerful environmental factors influencing inflammation, oxidative stress, hormonal regulation, and metabolic health. Unlike age or inherited susceptibility, dietary habits are largely within an individual's control, making nutrition an attractive target for prevention. Importantly, no single food causes or cures BPH. Rather, prostate health appears to reflect the cumulative effects of an individual's overall dietary pattern over many years. Men who consistently consume anti-inflammatory plant-rich diets generally have a lower risk of symptomatic BPH than those whose diets are dominated by highly processed foods and excess calories. Evidence from population studies. Numerous large observational studies have investigated the relationship between diet and BPH. Among the most influential are the Health Professionals Follow-up Study, the Prostate Cancer Prevention Trial, and analyses of data from the National Health and Nutrition Examination Survey (NHANES) in the United States. Although these studies differ in design and population, their findings are remarkably consistent. Dietary patterns associated with chronic inflammation tend to be linked with a greater likelihood of prostate enlargement and lower urinary tract symptoms, whereas diets rich in plant foods are generally associated with a lower risk. This consistency across diverse populations strengthens confidence that diet plays a genuine role in prostate health, even though observational studies cannot prove cause and effect. The Dietary Inflammatory Index. One useful way of evaluating diet is through the Dietary Inflammatory Index, DII. Rather than examining individual nutrients in isolation, the DII estimates the overall inflammatory potential of a person's diet. Foods that increase inflammatory markers raise the DII score, whereas foods known to suppress inflammation lower it. A high DII score typically reflects frequent consumption of refined carbohydrates, added sugars, processed meats, red meat, saturated fats, trans fats, ultra-processed foods, and excess calories. Conversely, a low DII score reflects diets rich in vegetables, fruits, legumes, whole grains, herbs and spices, nuts, seeds, olive oil, and other minimally processed plant foods. Human studies consistently demonstrate a dose-dependent relationship between higher DII scores and increased BPH risk. Men consuming the most pro-inflammatory diets are significantly more likely to develop enlarged prostates and troublesome urinary symptoms than those consuming anti-inflammatory diets. Experimental studies support these observations. Laboratory animals fed pro-inflammatory diets develop larger prostates, more extensive epithelial hyperplasia, increased collagen deposition, and markedly elevated inflammatory cytokines such as interleukin-6, tumor necrosis factor alpha, and interleukin-1 beta. Together, these findings strengthen the hypothesis that diet influences prostate enlargement through inflammatory mechanisms rather than acting solely through hormonal pathways. Metabolic syndrome, linking diet to the prostate. Diet affects the prostate indirectly through its influence on metabolic health. Metabolic syndrome refers to a cluster of interconnected disorders that include central obesity, insulin resistance, elevated blood glucose, hypertension, and abnormal blood lipid concentrations. Individually, each increases cardiovascular risk. Together, they also appear to promote BPH. Excess body fat, particularly abdominal fat, is not merely an energy store. Adipose tissue functions as an active endocrine organ that continuously releases inflammatory cytokines, hormones, and adipokines into the circulation. As body fat increases, so too does chronic systemic inflammation. This inflammatory state affects numerous organs, including the prostate. Men with obesity and metabolic syndrome are more likely to develop larger prostates, experience more severe lower urinary tract symptoms, and require surgical intervention. Insulin resistance may further contribute by increasing circulating insulin and insulin-like growth factor 1, IGF-1, both of which stimulate cellular proliferation and inhibit apoptosis. In effect, the prostate receives repeated biochemical signals, encouraging continued growth. The observation that obesity, diabetes, and BPH frequently coexist is therefore unlikely to be coincidental. They share many of the same underlying inflammatory and metabolic mechanisms. Oxidative stress, another important mechanism. Inflammation rarely acts alone. Virtually every inflammatory process generates reactive oxygen species, highly reactive molecules capable of damaging DNA, proteins, and cell membranes. Normally, the body possesses an extensive antioxidant defense system that neutralizes these compounds. However, when reactive oxygen species are produced faster than they can be eliminated, oxidative stress develops. Oxidative stress damages prostatic cells, activates inflammatory pathways, and stimulates further tissue remodeling. It also accelerates cellular aging and promotes the senescence-associated secretory phenotype described earlier. Poor dietary habits significantly worsen oxidative stress. Highly processed foods are generally rich in calories but relatively poor in antioxidants. Conversely, vegetables, fruits, herbs, spices, legumes, and whole grains contain thousands of naturally occurring antioxidant compounds, including carotenoids, flavonoids, polyphenols, and vitamin C, that help neutralize reactive oxygen species before they damage tissues. Although antioxidant supplements have produced inconsistent results in clinical trials, diets naturally rich in antioxidant-containing foods consistently correlate with better long-term health outcomes. Hormones and diet. Hormones remain central to the biology of BPH, but diet influences hormonal balance in several important ways. The prostate depends upon dihydrotestosterone, DHT, which is produced from testosterone by the enzyme 5-alpha reductase. DHT binds strongly to androgen receptors within prostatic cells, stimulating cellular growth and maintaining prostate tissue throughout adult life. Several dietary constituents appear capable of modifying these pathways. Isoflavones found in soy foods may modestly inhibit both 5-alpha reductase and aromatase, the enzyme responsible for converting testosterone into estrogen. This dual effect may partially explain why populations consuming traditional soy-rich diets historically experienced lower rates of prostate disorders. Plant sterols such as beta-sitosterol may also influence androgen metabolism while exerting anti-inflammatory effects. Importantly, these dietary effects are generally modest. They should be viewed as contributing to long-term risk reduction rather than acting as pharmaceutical alternatives. Why dietary patterns matter more than individual nutrients. Nutrition research has increasingly moved away from the reductionist idea that one nutrient determines health. Foods are extraordinarily complex biological packages containing thousands of interacting compounds. Tomatoes, for example, provide not only lycopene but also vitamin C, potassium, folate, flavonoids, fiber, and numerous lesser-known phytochemicals. Their benefits cannot be attributed to lycopene alone. Likewise, olive oil contains monounsaturated fats together with a rich mixture of polyphenols. Legumes provide fiber, resistant starch, plant protein, minerals, and dozens of bioactive compounds that interact with one another in ways that isolated supplements cannot replicate. For this reason, dietary patterns consistently outperform individual nutrients in predicting health outcomes. The strongest evidence therefore supports diets characterized by abundant vegetables and fruits, legumes, whole grains, nuts and seeds, olive oil, moderate consumption of fish, and minimal intake of red meat, processed meat, and ultra-processed foods. This dietary pattern closely resembles the traditional Mediterranean diet, which has repeatedly been associated with lower rates of cardiovascular disease, type 2 diabetes, certain cancers, and increasingly benign prostatic hyperplasia. In the next section, we shall examine the specific foods, nutrients, and phytochemicals that appear to offer the greatest protection against prostate enlargement and lower urinary tract symptoms. Part 3. Foods and nutrients that support prostate health. While no individual food can prevent or cure benign prostatic hyperplasia, BPH, a substantial body of research indicates that certain dietary patterns and foods are consistently associated with a lower risk of prostate enlargement and milder lower urinary tract symptoms. These foods share several common characteristics. They are rich in antioxidants, anti-inflammatory phytochemicals, dietary fiber, and essential micronutrients, while generally being low in saturated fat and highly processed ingredients. Rather than acting through a single mechanism, these foods appear to influence multiple biological pathways simultaneously. They reduce oxidative stress, suppress inflammatory signaling, improve insulin sensitivity, support a healthy gut microbiome, promote vascular health, and, in some cases, modestly influence androgen metabolism. Collectively, these effects create a physiological environment less conducive to chronic inflammation and abnormal prostate growth. Vegetables, the cornerstone of prostate health. Among all food groups, vegetables have the strongest and most consistent association with reduced BPH risk. Large prospective studies have found that men consuming at least 4 servings of vegetables daily have approximately 1/3 lower risk of developing symptomatic BPH than those with the lowest vegetable intake. Although all vegetables contribute beneficial nutrients, some appear particularly protective. Cruciferous vegetables, including broccoli, cauliflower, Brussels sprouts, cabbage, kale and bok choy, are especially valuable. These vegetables contain glucosinolates, which are converted during chewing into biologically active compounds such as sulforaphane and indole-3-carbinol. These phytochemicals possess potent antioxidant and anti-inflammatory properties and have been shown experimentally to suppress inflammatory pathways, enhance detoxification enzymes and protect cells from oxidative damage. Sulforaphane also appears to influence gene expression through activation of the NRF2 pathway, a master regulator of cellular antioxidant defenses. By enhancing the body's own protective mechanisms, cruciferous vegetables may help reduce the chronic inflammatory environment that drives BPH. Dark green leafy vegetables such as spinach, silver beet, mustard greens and collard greens are equally important. They provide abundant lutein, zeaxanthin, beta-carotene, folate, magnesium and vitamin C, together with numerous flavonoids that protect tissues from oxidative injury. Orange and yellow vegetables, including carrots, pumpkin and sweet potatoes, are excellent sources of beta-carotene and other carotenoids, which help neutralize reactive oxygen species generated during chronic inflammation. Collectively, these vegetables provide thousands of phytochemicals that work synergistically, illustrating why whole foods are generally more beneficial than isolated supplements. Tomatoes and lycopene. Among individual foods, tomatoes have attracted particular scientific interest because they are the richest dietary source of lycopene. Lycopene is a bright red carotenoid with exceptionally powerful antioxidant properties. Unlike many antioxidants, lycopene accumulates preferentially within prostate tissue, where it may help reduce oxidative damage and inflammation. Observational studies have repeatedly associated higher lycopene intake with lower rates of prostate disease. Several small clinical studies have also reported improvements in prostate-specific antigen, PSA, International Prostate Symptom Score, IPSS, and prostate volume following increased lycopene consumption, although larger trials are still needed. An interesting feature of lycopene is that cooking substantially increases its bioavailability. Heat breaks down the plant cell walls, making lycopene easier to absorb. Tomato paste, tomato puree, tomato soup and tomato sauces therefore often provide more absorbable lycopene than raw tomatoes. Absorption is enhanced further when tomatoes are consumed with a source of healthy fat, such as extra virgin olive oil or avocado, because lycopene is a fat-soluble compound. Other useful dietary sources include watermelon, pink grapefruit, guava and apricots, although tomatoes remain the principal source in most diets. Fruits, more than natural sweetness. Fruit contributes far more than vitamins. Berries, citrus fruits, apples, grapes, pomegranates and numerous other fruits contain diverse polyphenols that help regulate inflammation and oxidative stress. Blueberries, strawberries, raspberries and blackberries are particularly rich in anthocyanins, pigments responsible for their deep colors and strong antioxidant activity. These compounds have demonstrated anti-inflammatory, vascular protective and immune-modulating properties in numerous experimental studies. Citrus fruits provide abundant vitamin C together with flavonoids such as hesperidin and naringenin, which contribute additional antioxidant effects. Pomegranates contain elagitannins and other polyphenols that have attracted considerable research interest in prostate health. While evidence regarding BPH remains limited, their potent antioxidant properties support inclusion within an overall anti-inflammatory dietary pattern. Importantly, whole fruits should be preferred over fruit juices. The fiber present in intact fruit slows sugar absorption, promotes satiety, and supports a healthier gut microbiome. Legumes, plant protein with multiple benefits. Beans, lentils, chickpeas and peas represent one of the healthiest sources of dietary protein. Unlike animal protein, legumes contain virtually no cholesterol, very little saturated fat and abundant dietary fiber. They are also rich in folate, magnesium, potassium and numerous polyphenols. Replacing part of one's intake of red meat with legumes reduces saturated fat consumption while simultaneously increasing fiber intake and lowering the overall inflammatory potential of the diet. Legumes also support beneficial intestinal bacteria, which ferment dietary fiber into short-chain fatty acids such as butyrate. These compounds help maintain intestinal integrity and appear to reduce systemic inflammation through multiple mechanisms. Soy foods and isoflavones. Among legumes, soy deserves special attention. Traditional soy foods, including tofu, tempeh, edamame, and unsweetened soy milk, contain naturally occurring isoflavones such as genistein and daidzein. These compounds are classified as phytoestrogens because they possess weak, estrogen-like activity. However, their biological effects are complex and cannot be equated with human estrogen. Laboratory studies suggest that soy isoflavones may inhibit the enzymes 5-alpha reductase and aromatase, thereby modestly influencing androgen and estrogen metabolism within the prostate. They also exhibit anti-inflammatory, antioxidant, and anti-proliferative properties. Although human studies have produced mixed results, populations consuming traditional soy-rich diets generally experience lower rates of several prostate disorders, suggesting that soy may contribute to long-term prostate health when incorporated as part of an overall plant-based dietary pattern. Whole soy foods are preferable to highly processed soy isolates or concentrated supplements. Nuts, seeds, and healthy fats. Regular consumption of nuts and seeds has repeatedly been associated with reduced cardiovascular disease, improved metabolic health, and lower levels of systemic inflammation. Walnuts provide alpha-linolenic acid, ALA, a plant-derived omega-3 fatty acid together with polyphenols and vitamin E. Flax seeds contain abundant lignans and soluble fiber, both of which may influence hormone metabolism and support gut health. Pumpkin seeds have long been associated with prostate health in traditional medicine. Modern research suggests they provide useful quantities of zinc, magnesium, healthy fats, and phytosterols. Some clinical studies have reported modest improvements in urinary symptoms among men consuming pumpkin seed preparations, although larger trials are required. Sesame seeds similarly contribute minerals, lignans, and antioxidant compounds. Avocados are another valuable addition to an anti-inflammatory diet. They provide monounsaturated fats, fiber, potassium, and beta-sitosterol, a naturally occurring plant sterol that has demonstrated modest improvements in urinary symptoms in some clinical trials. Olive oil and the Mediterranean pattern. Extra virgin olive oil occupies a central position in the Mediterranean diet and appears to contribute significantly to its health benefits. Unlike refined vegetable oils, extra virgin olive oil retains a rich mixture of polyphenols with potent antioxidant and anti-inflammatory activity. Together with its high content of monounsaturated fatty acids, these compounds improve endothelial function, reduce oxidative stress, and suppress inflammatory signaling pathways. The Mediterranean dietary pattern, characterized by abundant vegetables, fruits, legumes, whole grains, olive oil, nuts, and moderate fish consumption, has consistently been associated with lower international prostate symptom scores and improved urinary flow in observational studies. Importantly, it is the overall dietary pattern rather than olive oil alone that appears most beneficial. Fish and omega-3 fatty acids. Oily fish such as smash, salmon, mackerel, anchovy, sardines, and herring, as well as trout, provide the long-chain omega-3 fatty acids EPA and DHA. These fatty acids give rise to specialized molecules known as resolvins and protectins, which actively promote the resolution of inflammation rather than merely suppressing it. Although evidence specific to BPH remains limited, several studies suggest that men consuming higher amounts of omega-3 fatty acids may experience improved urinary symptoms and better responses to conventional therapy. Fish also provides high-quality protein, vitamin D, and selenium while replacing red meat, thereby contributing to an overall anti-inflammatory dietary pattern. Beyond meat reduction, the advantages of replacing animal protein with whole plant foods. Reducing red and processed meat intake is only one part of the equation. An equally important question is, what should replace it? Simply substituting one animal food for another may offer modest benefits, but replacing a significant proportion of animal protein with whole plant foods appears to confer much greater health advantages. Legumes, including beans, lentils, chickpeas, and peas, together with whole soy foods, nuts, and seeds provide high-quality protein accompanied by dietary fiber, complex carbohydrates, vitamins, minerals, and an extraordinary diversity of phytochemicals. Unlike animal foods, these plant foods contain no cholesterol and are generally low in saturated fat while being naturally rich in antioxidants and anti-inflammatory compounds. This combination of nutrients influences multiple biological systems simultaneously, producing health benefits that extend far beyond the prostate. Supporting a healthy gut microbiome. One of the most important discoveries in modern nutritional science is the central role of the gut microbiome. The human large intestine is home to trillions of microorganisms, representing hundreds of bacterial species. Far from being passive inhabitants, these microbes actively participate in digestion, immune regulation, vitamin synthesis, and the metabolism of numerous dietary compounds. Collectively, they function almost like an additional organ. Diet is one of the principal factors determining which microbial species flourish. Whole plant foods are rich in dietary fiber and resistant starch, neither of which can be digested by human enzymes. Instead, these carbohydrates reach the large intestine intact, where they are fermented by beneficial bacteria. This fermentation produces short-chain fatty acids, SCFAs, primarily acetate, propionate, and butyrate, which perform numerous protective functions. Butyrate, in particular, serves as the preferred fuel for the cells lining the colon. It strengthens the intestinal barrier, reducing the leakage of bacterial toxins and inflammatory molecules into the bloodstream. It also exerts potent anti-inflammatory effects by suppressing nuclear factor kappa B, NF-kappa B, one of the master regulators of inflammation. A healthy, fiber-rich microbiome therefore contributes to lower levels of systemic inflammation, which may indirectly benefit the prostate by reducing the chronic inflammatory environment associated with BPH. By contrast, diets rich in animal protein but poor in fiber encourage the growth of different bacterial populations that produce potentially harmful metabolites, including ammonia, hydrogen sulfide, branched-chain fatty acids, and compounds derived from choline and L-carnitine that are converted into trimethylamine N-oxide, TMAO. Elevated TMAO concentrations have been associated with atherosclerosis, cardiovascular disease, and chronic inflammation. Thus, replacing meat with legumes and other whole plant foods not only changes nutrient intake but fundamentally reshapes the microbial ecosystem within the intestine. Improving insulin sensitivity. Whole plant foods also exert powerful effects on glucose metabolism. Because they are rich in fiber and structurally complex, legumes and whole grains are digested more slowly than refined carbohydrates or many animal-based meals. This results in a more gradual rise in blood glucose and insulin concentrations following meals. Improved insulin sensitivity reduces circulating insulin and insulin-like growth factor 1, IGF-1, both of which promote cellular proliferation and inhibit programmed cell death. Lower exposure to these growth-promoting hormones may help slow abnormal tissue growth within the prostate, while simultaneously reducing the risk of type 2 diabetes and cardiovascular disease. Numerous intervention studies have demonstrated that diets emphasizing whole plant foods improve insulin sensitivity, reduce fasting blood glucose, and lower glycated hemoglobin, HbA1c, even in individuals with established diabetes. These metabolic improvements complement the anti-inflammatory effects of plant-based diets and contribute to healthier aging. Reducing chronic systemic inflammation. Perhaps the greatest advantage of whole plant foods lies in their remarkable anti-inflammatory potential. Plants manufacture thousands of bioactive compounds, including polyphenols, flavonoids, carotenoids, glucosinolates, lignans, and isoflavones, to protect themselves from environmental stress. When consumed, many of these phytochemicals also exert beneficial effects within the human body. They help neutralize reactive oxygen species, suppress inflammatory signaling pathways such as NF-kappa B and JAK-STAT, modulate immune cell activity, and enhance the body's own antioxidant defense systems through activation of the NRF2 pathway. Unlike pharmaceutical anti-inflammatory drugs, which generally target one or two biochemical pathways, diets rich in whole plant foods influence numerous pathways simultaneously, producing broad yet physiologically balanced reductions in chronic inflammation. This is particularly relevant to BPH, where inflammation is increasingly recognized as a central driver of stromal proliferation, fibrosis, and progressive enlargement of the prostate. Promoting healthy body weight. Whole plant foods also possess a lower energy density than most animal-derived foods. Vegetables, fruits, legumes, and whole grains contain large amounts of water and dietary fiber, allowing individuals to consume satisfying portions while ingesting fewer kilocalories. Dietary fiber slows gastric emptying, prolongs satiety, and reduces spontaneous calorie intake. Consequently, diets centered on whole plant foods facilitate healthy weight management without requiring severe calorie restriction. Maintaining a healthy body weight reduces adipose tissue mass, thereby lowering production of inflammatory cytokines such as tumor necrosis factor alpha, TNF-alpha, and interleukin-6, IL-6. This reduction in systemic inflammation benefits not only the cardiovascular system but also the aging prostate. Supporting healthy aging. The same dietary pattern associated with lower BPH risk is also consistently associated with healthier aging. Large prospective studies have shown that individuals consuming predominantly whole plant foods experience lower rates of coronary heart disease, stroke, hypertension, type 2 diabetes, chronic kidney disease, and several common cancers. They also tend to maintain better physical function and cognitive performance later in life. Many of these benefits appear to arise from the combined effects of reduced oxidative stress, lower systemic inflammation, improved vascular function, healthier body weight, and a more diverse gut microbiome. Emerging evidence also suggests that plant-rich diets may influence the biology of aging itself by reducing the accumulation of senescent cells and attenuating the senescence-associated secretory phenotype, SASP. Because SASP contributes to the chronic inflammatory state known as inflammaging, suppressing these pathways may help slow the progression of multiple age-related disorders including BPH. More than the absence of meat. It is therefore important to appreciate that the benefits of plant-based eating do not arise simply because meat has been removed from the diet. Rather, they result from replacing meat with foods that actively promote health through multiple complementary mechanisms. Legumes, whole grains, vegetables, fruits, nuts and seeds nourish beneficial gut microbes, improve insulin sensitivity, reduce chronic inflammation, provide abundant antioxidants and phytochemicals, facilitate healthy weight management, and support cardiovascular and metabolic health. These effects are synergistic. Together they create a physiological environment that is less favorable to the chronic inflammatory processes underlying benign prostatic hyperplasia and many other diseases of aging. Consequently, dietary advice should focus not merely on reducing potentially harmful foods, but on increasing the regular consumption of whole, minimally processed plant foods. This positive approach shifts the emphasis from dietary restriction to dietary enrichment, encouraging a pattern of eating that supports lifelong health rather than simply avoiding disease. In this broader context, replacing animal protein with whole plant foods represents one of the most powerful nutritional strategies currently available for promoting healthy aging, reducing chronic disease risk, and supporting long-term prostate health. A whole diet perspective. Perhaps the most important lesson from nutritional research is that foods rarely act in isolation. A meal consisting of grilled salmon, steamed broccoli, tomatoes drizzled with extra virgin olive oil, lentils and fresh berries provides hundreds of bioactive compounds working together. By contrast, no capsule can replicate this extraordinary biochemical complexity. For this reason, the greatest benefits are observed not from isolated superfoods, but from consistently consuming an overall dietary pattern centered on whole, minimally processed plant foods, healthy fats and moderate amounts of fish, while limiting foods known to promote chronic inflammation. In the next section, we shall examine the foods and dietary habits that appear to increase the risk of benign prostatic hyperplasia and accelerate its progression. Part 4. Dietary factors that increase the risk of benign prostatic hyperplasia. While certain foods appear to protect the prostate, others are consistently associated with an increased risk of benign prostatic hyperplasia, BPH, and more severe lower urinary tract symptoms. These foods share a common characteristic. They promote chronic inflammation, oxidative stress, and metabolic dysfunction, creating an internal environment that favors continued prostate enlargement. Importantly, no single meal causes BPH. Rather, the condition develops gradually over many years as the cumulative effects of dietary habits interact with aging, genetics, and hormonal changes. Men who habitually consume highly processed, energy-dense diets tend to experience greater systemic inflammation, which increasingly appears to play a central role in the development and progression of BPH. The Western dietary pattern. The dietary pattern most consistently associated with increased BPH risk is the so-called Western diet. This pattern is characterized by frequent consumption of red meat, processed meat, refined grains, white bread, pastries, confectionery, sugar-sweetened beverages, deep-fried foods, fast food, processed snacks, ultra-processed foods, and excessive calorie intake. Such diets are typically low in dietary fiber, antioxidants and phytochemicals, yet rich in refined starches, unhealthy fats, added sugars and sodium. Collectively, these characteristics promote obesity, insulin resistance, and chronic low-grade inflammation. Large epidemiological studies have repeatedly shown that men whose diets most closely resemble the Western pattern are more likely to develop symptomatic BPH than those consuming predominantly plant-based diets. Red and processed meat. Among individual foods, red meat has received considerable attention. Several large prospective studies have reported that frequent consumption of beef, lamb, and pork is associated with an increased likelihood of BPH. In one major clinical trial, men who consumed red meat daily had approximately a 38% higher risk of developing BPH than those who ate it less frequently. The explanation is unlikely to be attributable to a single component of meat. Rather, several mechanisms probably contribute simultaneously. Red meat is often rich in saturated fat, iron, and advanced glycation end products, particularly when cooked at high temperatures. Processing methods such as curing, smoking, and preservation may introduce additional compounds, including nitrates and nitrites, while grilling and barbecuing can generate heterocyclic amines and polycyclic aromatic hydrocarbons. Many of these compounds promote oxidative stress and inflammatory signaling throughout the body. Moreover, diets high in red meat frequently displace vegetables, legumes, and other protective plant foods, reducing the overall intake of antioxidants and dietary fiber. Red and processed meat and cancer risk. The association between red and processed meat and benign prostatic hyperplasia should also be considered within the broader context of their effects on long-term health. Over the past several decades, a substantial body of epidemiological research has linked high consumption of these foods with an increased risk of several forms of cancer. Red meat refers to unprocessed mammalian meat, including beef, pork, lamb, mutton, goat, and veal. Processed meat includes meat that has been preserved by salting, curing, smoking, fermentation, or the addition of chemical preservatives. Common examples include bacon, ham, sausages, salami, pepperoni, corned beef, hot dogs, and many luncheon meats. In 2015, the International Agency for Research on Cancer, IARC, comprehensively reviewed more than 800 epidemiological studies from around the world. After evaluating the available evidence, it classified processed meat as Group 1, carcinogenic to humans, indicating that there is sufficient evidence that it causes cancer in humans. Red meat was classified as Group 2A, probably carcinogenic to humans, reflecting strong evidence from epidemiological studies together with supporting mechanistic evidence. It is important to understand what these classifications mean. They describe the strength of the scientific evidence that a substance can cause cancer under some circumstances. They do not indicate the magnitude of the risk. For example, tobacco smoking and processed meat both fall into Group 1 because the evidence that they can cause cancer is strong, but smoking increases cancer risk by a far greater degree than processed meat. The strongest evidence concerns colorectal cancer, for which the association with processed meat is considered convincing. High consumption of red and processed meat has also been linked, with varying degrees of evidence, to cancers of the stomach, pancreas, and prostate, although the evidence for these cancers is generally less consistent than for colorectal cancer. Several biological mechanisms may explain these associations. Red meat contains abundant iron, which can promote the formation of reactive oxygen species and potentially carcinogenic N-nitroso compounds within the gastrointestinal tract. Processing methods such as curing and smoking may introduce additional carcinogenic compounds, including nitrates and nitrites, which can also be converted into N-nitroso compounds under certain conditions. Cooking meat at very high temperatures, particularly grilling, barbecuing, pan-frying, or flame broiling, can generate heterocyclic amines (HCAs) and polycyclic aromatic hydrocarbons (PAHs). Experimental studies have shown that many of these compounds can damage DNA and increase cancer risk. Although occasional consumption is unlikely to pose a significant hazard, frequent intake over many decades may contribute to cumulative risk. Another concern is that diets high in red and processed meat are often accompanied by relatively low intakes of vegetables, fruits, legumes, and whole grains. Consequently, individuals may consume fewer dietary fiber, antioxidants, and phytochemicals, all of which help protect against oxidative stress, chronic inflammation, and DNA damage. In many cases, therefore, the health effects reflect not only what is eaten but also what is displaced from the diet. From a prostate health perspective, reducing red and processed meat intake offers several potential advantages. It lowers consumption of saturated fat and pro-inflammatory compounds, while creating room for healthier protein sources such as legumes, soy foods, nuts, and seeds. For those who consume animal products, fish and poultry generally represent more favorable choices than processed meats or large quantities of red meat. Current evidence therefore supports limiting, rather than necessarily eliminating, red meat while avoiding processed meat whenever possible. Such an approach aligns not only with recommendations for reducing the risk of BPH, but also with broader dietary guidelines aimed at lowering the incidence of colorectal cancer, cardiovascular disease, and other chronic illnesses. In practical terms, replacing even a few weekly servings of red or processed meat with beans, lentils, chickpeas, tofu, or other whole plant foods can substantially improve the overall nutritional quality and anti-inflammatory potential of the diet while supporting long-term health. Saturated fat and excess dietary fat. Earlier studies suggested that high total fat intake increased BPH risk. More recent research indicates that the quality of dietary fat may be more important than the total amount consumed. Diets high in saturated fat are associated with greater inflammation, impaired insulin sensitivity, and obesity. These changes indirectly influence prostate health through multiple pathways. The evidence regarding polyunsaturated fatty acids is more complex. Some observational studies have linked very high intakes of omega-6 rich oils with increased BPH risk, although findings remain inconsistent and may reflect the broader dietary context rather than the oils themselves. What appears increasingly clear is that replacing saturated fats with healthier unsaturated fats from whole plant foods and extra virgin olive oil is associated with improved metabolic health and lower inflammatory burden. Refined carbohydrates and added sugars. Refined carbohydrates are another hallmark of the Western diet. Unlike intact whole grains, refined grains have had much of their fiber, vitamins, and phytochemicals removed during processing. White bread, polished rice, refined breakfast cereals, cakes, biscuits, and many packaged snack foods produce rapid rises in blood glucose and insulin concentrations. Repeated spikes in insulin encourage insulin resistance over time, contributing to metabolic syndrome. Elevated insulin and insulin-like growth factor 1, IGF-1, may stimulate cellular proliferation within the prostate while reducing apoptosis, thereby favoring continued enlargement. Added sugars compound these effects by increasing calorie intake without providing meaningful nutritional value. Regular consumption of sugar-sweetened beverages and highly processed desserts contributes to weight gain, fatty liver disease, and chronic systemic inflammation, all of which are linked with poorer prostate health. Ultra-processed foods. The concept of ultra-processed foods has emerged as an important area of nutritional research. These products are industrial formulations manufactured largely from refined ingredients and food additives rather than whole foods. Examples include packaged snack foods, instant noodles, processed meats, confectionery, sugary breakfast cereals, soft drinks, frozen ready meals, and many commercially baked products. Ultra-processed foods are generally high in refined starches, unhealthy fats, salt, and added sugars, while being low in fiber and protective phytochemicals. Their frequent consumption is strongly associated with obesity, type 2 diabetes, cardiovascular disease, and several cancers. Although research specifically examining BPH remains relatively limited, the inflammatory and metabolic consequences of ultra-processed foods provide compelling biological reasons to minimize their intake. Excess energy intake. The quantity of food consumed may be just as important as its quality. Habitual overconsumption of calories leads to positive energy balance, progressive weight gain, and expansion of adipose tissue. As previously discussed, excess adipose tissue functions as an endocrine organ that continually releases inflammatory cytokines into the bloodstream. Obesity therefore represents an important intermediary between diet and prostate enlargement. Maintaining a healthy body weight through appropriate calorie intake and regular physical activity appears to reduce both the likelihood of developing BPH and the severity of urinary symptoms in affected men. Dietary calcium, an area of ongoing investigation. Dietary calcium deserves brief mention because research findings have been somewhat inconsistent. Several observational studies have reported that higher calcium intake is associated with a modest increase in the likelihood of BPH, particularly among older men. Analyses of NHANES data suggested that each additional 100 mg of daily calcium intake was associated with slightly higher odds of developing the condition. However, these studies do not establish causation, and the underlying biological mechanisms remain uncertain. Calcium is an essential nutrient required for bone health, muscle contraction, and numerous cellular functions. There is currently insufficient evidence to recommend restricting calcium intake solely for the prevention or treatment of BPH. Instead, men should aim to obtain appropriate amounts from a balanced diet while avoiding unnecessary high-dose supplementation unless medically indicated. Alcohol. The relationship between alcohol and BPH is complex. Some observational studies have reported that moderate alcohol consumption is associated with a lower risk of symptomatic BPH, possibly through effects on insulin sensitivity or cardiovascular health. Other studies have found no significant association, while excessive alcohol intake clearly carries numerous adverse health consequences. Given these inconsistent findings, alcohol should not be regarded as a strategy for preventing BPH. Any potential benefits are outweighed by its well-established risks when consumed in excess. The importance of overall dietary pattern. Perhaps the most significant lesson from nutritional science is that foods do not act independently. A diet rich in vegetables, legumes, whole grains, and fruit may offset some of the adverse effects of occasional indulgence, whereas frequent consumption of highly processed foods creates a persistently pro-inflammatory internal environment. Researchers increasingly evaluate diets using indices such as the Dietary Inflammatory Index because they recognize that the overall dietary pattern is far more informative than any individual nutrient. Men whose diets have the highest inflammatory scores consistently exhibit a greater risk of prostate enlargement, more severe urinary symptoms, and faster disease progression. Conversely, those consuming diets rich in minimally processed plant foods tend to experience lower levels of systemic inflammation and better long-term prostate health. These observations reinforce an important principle. Preventing BPH is not about avoiding a single food, but about adopting a dietary pattern that consistently supports metabolic health and suppresses chronic inflammation. In the next section, we shall explore the many factors beyond diet that influence prostate health, including obesity, physical inactivity, smoking, hormonal changes, infections, oxidative stress, and the aging process itself, and how these interact with nutrition to shape the development and progression of benign prostatic hyperplasia. Part 5. Beyond diet. Lifestyle, metabolic health, and other factors that influence BPH. Diet is one of the most important modifiable influences on benign prostatic hyperplasia (BPH), but it does not act in isolation. The prostate is affected by the cumulative interaction of aging, hormonal regulation, metabolic health, physical activity, vascular function, immune responses, and environmental exposures. These factors often reinforce one another, creating either a favorable environment that supports healthy aging or one that perpetuates chronic inflammation and abnormal tissue growth. Understanding these interactions provides a more complete picture of why some men develop severe BPH, while others experience few or no symptoms despite reaching an advanced age. Obesity, more than excess body weight. Obesity is among the strongest modifiable risk factors for BPH. For many years, excess body weight was viewed largely as a mechanical problem affecting mobility and cardiovascular health. Today, adipose tissue is recognized as a highly active endocrine organ that secretes a wide range of biologically active substances, including inflammatory cytokines, hormones, and adipokines. As fat mass increases, particularly around the abdomen, production of inflammatory mediators such as tumor necrosis factor alpha, TNF-alpha, interleukin-6, IL-6, and leptin also increases, while protective adiponectin levels often decline. This chronic inflammatory state extends throughout the body, including the prostate, where it promotes cellular proliferation, fibrosis, and tissue remodeling. Obesity is also associated with increased aromatase activity. Aromatase converts testosterone into estrogen, altering the balance between male and female sex hormones. Although testosterone remains essential for prostate function, changes in the androgen to estrogen ratio may influence inflammatory pathways and stromal proliferation within the aging prostate. Men with obesity are therefore more likely to develop larger prostates, experience more severe lower urinary tract symptoms, and require surgical intervention than men who maintain a healthy body weight. Insulin resistance and type 2 diabetes. Insulin resistance provides another important link between nutrition and prostate health. When body tissues become less responsive to insulin, the pancreas compensates by producing increasing amounts of the hormone. This state of hyperinsulinemia stimulates the production of insulin-like growth factor 1, IGF-1, a powerful promoter of cell growth and proliferation. Both insulin and IGF-1 can encourage prostatic cells to multiply while reducing normal programmed cell death. Over many years, these growth-promoting signals may contribute to enlargement of the prostate. Type 2 diabetes also accelerates oxidative stress, impairs blood vessel function, and increases systemic inflammation, all of which further aggravate the chronic inflammatory environment associated with BPH. Fortunately, dietary measures that improve insulin sensitivity, such as maintaining a healthy body weight, consuming whole plant foods, and engaging in regular physical activity, also benefit prostate health. Physical activity. Exercise complements nutrition in several important ways. Regular physical activity improves insulin sensitivity, assists weight management, lowers blood pressure, reduces systemic inflammation, and enhances cardiovascular health. It also improves pelvic blood flow and supports normal bladder function. Large observational studies consistently show that physically active men have a lower risk of developing symptomatic BPH than sedentary men. Exercise may also improve existing urinary symptoms. Men who remain physically active often report less urinary urgency, fewer nocturnal awakenings, and better overall quality of life. The precise form of exercise appears to be less important than long-term consistency. Brisk walking, cycling, swimming, resistance training, and other moderate forms of physical activity all contribute to improved metabolic health. Current public health recommendations of at least 150 minutes of moderate intensity exercise each week are likely to benefit both cardiovascular and prostate health. Smoking. Although smoking is more strongly associated with cardiovascular disease, chronic lung disease, and cancer, it also adversely affects the prostate. Tobacco smoke contains thousands of chemicals capable of generating oxidative stress and damaging blood vessels. Chronic smoking reduces tissue oxygenation, promotes inflammation, and impairs microvascular circulation throughout the body. Within the prostate, reduced blood flow may contribute to local hypoxia, increased production of reactive oxygen species, and progressive fibrosis. Smoking has also been associated with greater severity of lower urinary tract symptoms and poorer postoperative outcomes following surgery for BPH. Stopping smoking therefore benefits virtually every aspect of health, including the urinary tract. Pelvic ischemia and reduced blood flow. Healthy tissues require an adequate blood supply to deliver oxygen and nutrients while removing metabolic waste products. Aging, hypertension, diabetes, smoking, and atherosclerosis progressively impair blood flow to many organs, including the prostate. Reduced oxygen delivery produces pelvic ischemia, a condition in which tissues experience chronic oxygen deprivation. Cells respond by generating reactive oxygen species and activating inflammatory pathways that stimulate angiogenesis, fibrosis, and tissue remodeling. These adaptive responses may initially help tissues survive but, over time, contribute to the structural changes characteristic of BPH. The same lifestyle measures that protect the cardiovascular system, including regular exercise, maintaining a healthy weight, and consuming an anti-inflammatory diet, also help preserve healthy blood flow to the prostate. Infection and chronic inflammation. Not all inflammation originates from diet or metabolic disease. Bacterial infections may initiate inflammatory responses that persist long after the original infection has resolved. Gram-negative bacteria are particularly implicated, although sexually transmitted infections caused by organisms such as Neisseria gonorrhoeae, Chlamydia trachomatis, Treponema pallidum, and Trichomonas vaginalis have also been investigated. Several viruses, including human papillomavirus (HPV), herpes simplex virus type 2, cytomegalovirus, and human herpes virus 8, have likewise been proposed as possible contributors, although the evidence remains less conclusive. These infections may disrupt the normal immune environment of the prostate, leading to persistent cytokine production and chronic inflammatory activation that favors tissue remodeling and hyperplasia. Fortunately, persistent infection accounts for only a minority of BPH cases, but prompt diagnosis and treatment of urinary or sexually transmitted infections remain important aspects of prostate health. Urinary reflux and mechanical irritation. Another proposed trigger is intraprostatic urinary reflux. Normally, urine passes through the urethra without entering the microscopic ducts of the prostate. Under certain circumstances, however, urine may reflux into these ducts, exposing prostatic tissues to irritating urinary constituents. Repeated chemical irritation may trigger local inflammation and activate wound healing responses that gradually contribute to hyperplasia. Similarly, repeated mechanical stress and microtrauma have been suggested as additional contributors, although their precise roles continue to be investigated. Autoimmunity. Some researchers believe that BPH may, in part, represent an autoimmune disorder. According to this hypothesis, the immune system mistakenly recognizes proteins produced by the prostate as foreign, initiating a persistent inflammatory response even in the absence of infection. Although definitive proof remains elusive, increasing evidence suggests that autoimmune mechanisms may contribute to chronic inflammation in susceptible individuals, particularly when combined with aging and metabolic dysfunction. Aging and inflammaging. Age remains the single greatest risk factor for BPH, but modern science has transformed our understanding of why aging exerts such a profound influence. Rather than representing simple biological wear and tear, aging is increasingly recognized as a state of chronic, low-grade inflammation, a phenomenon known as inflammaging. Over time, senescent cells accumulate throughout the body. These cells cease dividing but remain metabolically active, releasing inflammatory cytokines, chemokines, growth factors and tissue remodeling enzymes collectively known as the senescence-associated secretory phenotype, SASP. The prostate is particularly susceptible to these age-related changes. Instead of resolving after injury, inflammatory responses become persistent. Growth factors continue stimulating stromal and epithelial proliferation, while fibrosis progressively remodels the gland. This helps explain why BPH becomes increasingly common with advancing age, even in otherwise healthy men. Importantly, however, inflammaging is not entirely inevitable. Healthy dietary patterns, regular exercise, maintenance of normal body weight, and avoidance of smoking all appear capable of reducing the inflammatory burden associated with aging. A comprehensive lifestyle strategy. Taken together, current evidence indicates that BPH is best understood as a multifactorial disorder rather than simply an enlarged prostate caused by aging. Its development reflects decades of interaction among chronic inflammation, hormonal regulation, oxidative stress, obesity, insulin resistance, vascular health, immune function, and genetic susceptibility. Many of these influences are modifiable. Maintaining a healthy body weight, consuming an anti-inflammatory, predominantly plant-based diet, engaging in regular physical activity, avoiding smoking, limiting ultra-processed foods, controlling diabetes and hypertension, and promptly treating urinary tract infections represent practical strategies that may reduce the risk of developing BPH or slow its progression. These lifestyle measures complement, rather than replace, appropriate medical care. Men who experience persistent urinary symptoms should seek prompt medical evaluation to exclude other conditions, including prostate cancer, urinary tract infection, and neurological disorders. In the next section, we shall examine the evidence surrounding nutritional supplements, including saw palmetto, beta-sitosterol, pygeum and pumpkin seed extract, and compare popular claims with the findings of modern clinical research. Part 6. Nutritional Supplements. Separating evidence from marketing. The popularity of nutritional supplements for benign prostatic hyperplasia, BPH, has grown steadily over recent decades. Pharmacies, health food shops, and online retailers offer a bewildering array of products claiming to shrink the prostate, improve urinary flow, reduce nocturia, and restore normal bladder function. Among the most widely promoted are saw palmetto, beta-sitosterol, pygeum africanum, pumpkin seed extract, ryegrass pollen extract, zinc, and various antioxidant formulations. Despite their popularity, the scientific evidence supporting these products varies considerably. Some possess a plausible biological rationale and modest clinical evidence, whereas others have failed to demonstrate meaningful benefits when tested in large, well-designed clinical trials. For this reason, nutritional supplements should never be viewed as substitutes for a healthy diet or appropriate medical treatment. Rather, they should be regarded as adjunctive measures whose benefits, where they exist, are generally modest. Saw palmetto, the most studied herbal remedy. Saw palmetto, Serenoa repens, is undoubtedly the best-known herbal treatment for BPH. Extracts of its berries have been used for more than a century, largely because laboratory studies suggest they possess mild anti-inflammatory, anti-androgenic, and anti-estrogenic properties. They may partially inhibit the enzyme 5-alpha reductase, thereby reducing the formation of dihydrotestosterone (DHT), while also influencing inflammatory pathways within the prostate. These mechanisms initially generated considerable enthusiasm, and early clinical studies appeared promising. However, as larger and more rigorous trials were conducted, the picture became less encouraging. The most comprehensive evidence now comes from large systematic reviews and meta-analyses of randomized controlled trials. These analyses consistently conclude that standardized saw palmetto monotherapy provides little or no clinically meaningful improvement in lower urinary tract symptoms, urinary flow rates, or quality of life when compared with placebo. Even when statistically significant improvements have been observed, the changes have generally fallen well below the threshold considered clinically meaningful by patients. Several large National Institutes of Health-funded studies reached the same conclusion, demonstrating that even doses several times higher than those traditionally recommended failed to outperform placebo. As a result, major professional organizations including the American Urological Association (AUA), the National Institute for Health and Care Excellence (NICE) in the United Kingdom, and the Canadian Urological Association do not recommend saw palmetto as a routine treatment for BPH. This does not necessarily mean that every formulation is ineffective. Some European studies have reported more favorable outcomes using highly standardized hexanic lipidosterolic extracts, particularly preparations marketed under the name Permixin. A number of smaller studies have also suggested modest benefits when saw palmetto is combined with alpha blockers or other phytotherapeutic agents. Nevertheless, these findings remain inconsistent, and differences in extraction methods, product quality, and study design make direct comparison difficult. Overall, the current consensus is clear: saw palmetto is generally safe but provides little or no clinically meaningful benefit for most men when used alone. Beta-sitosterol. Among plant-derived compounds, beta-sitosterol has generated somewhat stronger evidence. Beta-sitosterol is a naturally occurring phytosterol found in avocados, nuts, seeds, legumes, and vegetable oils. It is also available as a concentrated supplement. Several clinical trials have demonstrated modest improvements in urinary symptom scores and urinary flow rates among men taking beta-sitosterol preparations. However, these improvements appear largely symptomatic rather than structural. There is little convincing evidence that beta-sitosterol reduces prostate size or alters the long-term progression of BPH. Nevertheless, it remains one of the more promising phytotherapeutic agents and appears to have an excellent safety profile. Obtaining beta-sitosterol naturally through foods such as avocados, pumpkin seeds, and other plant foods offers additional nutritional benefits beyond the compound itself. Pygeum africanum. Extracts derived from the bark of the African cherry tree, Pygeum africanum, have been used traditionally to relieve urinary symptoms. Laboratory studies indicate anti-inflammatory effects together with possible inhibition of fibroblast proliferation and growth factor signaling. Clinical trials have reported modest improvements in nocturia and urinary symptoms, but most studies have been relatively small and methodologically limited. Current evidence therefore remains insufficient to recommend Pygeum as a primary treatment. Pumpkin seed extract. Pumpkin seeds have long been regarded as a traditional remedy for prostate disorders. They provide zinc, magnesium, vitamin E, healthy unsaturated fats and phytosterols, together with numerous antioxidant compounds. Several clinical studies suggest that pumpkin seed extracts may modestly improve urinary symptoms, although their effects on prostate size appear minimal. The seeds themselves are nutritious foods and fit naturally within an anti-inflammatory dietary pattern. Consequently, regular consumption of whole pumpkin seeds is preferable to relying solely on supplements. Ryegrass pollen extract. Ryegrass pollen extract has also been investigated for BPH. Some studies report improvements in nocturia and subjective urinary symptoms, possibly through anti-inflammatory or smooth muscle relaxing effects. However, evidence remains inconsistent, and larger high-quality trials are required before firm recommendations can be made. Zinc. The prostate contains one of the highest concentrations of zinc found in the human body. Experimental studies suggest zinc plays important roles in antioxidant defense, immune regulation, and normal prostate function. Some observational studies have reported lower zinc concentrations in enlarged prostates, leading to speculation that supplementation might prove beneficial. However, evidence from clinical trials remains inconclusive. The best approach is therefore to obtain adequate zinc from foods naturally rich in the mineral, including legumes, whole grains, nuts, seeds, and seafood, rather than relying on high-dose supplements. Excessive zinc supplementation should be avoided, because prolonged high intakes may interfere with copper absorption and produce other adverse effects. Vitamin D. Vitamin D receptors are widely distributed throughout the prostate. Laboratory studies suggest vitamin D may regulate cell proliferation, immune responses, and inflammatory pathways. Several observational studies have reported that men with higher vitamin D intake or adequate blood vitamin D concentrations have a slightly lower risk of BPH. Nevertheless, evidence from supplementation trials remains limited. Men with confirmed vitamin D deficiency should receive appropriate treatment under medical supervision, but routine high-dose supplementation solely for BPH cannot currently be recommended. Curcumin and other plant polyphenols. Curcumin, the principal polyphenol found in turmeric, has attracted enormous scientific interest because of its powerful anti-inflammatory and antioxidant properties. Experimental studies demonstrate that curcumin suppresses multiple inflammatory pathways, including nuclear factor kappa B, NF-kappa B, cyclooxygenase 2, COX2, and several inflammatory cytokines implicated in BPH. Despite these promising laboratory findings, clinical evidence specifically relating to BPH remains limited. The same applies to numerous other polyphenols found in green tea, cocoa, berries, grapes, and pomegranates. These compounds undoubtedly contribute to the health benefits of diets rich in whole plant foods, but evidence supporting high-dose supplementation remains insufficient. Food first, supplements second. One of the most important lessons from modern nutritional science is that whole dietary patterns consistently outperform isolated supplements. Foods contain thousands of interacting nutrients and phytochemicals that cannot be replicated within a capsule. A tomato provides lycopene together with vitamin C, potassium, fiber, flavonoids, and numerous other compounds. Broccoli supplies sulforaphane alongside vitamin K, folate, fiber, and many additional phytochemicals. Walnuts provide omega-3 fatty acids, vitamin E, magnesium, polyphenols, and plant protein. These compounds interact synergistically in ways that reductionist supplementation rarely reproduces. Consequently, men seeking to support prostate health should regard supplements as secondary to a consistently healthy dietary pattern. Practical dietary recommendations. Current scientific evidence supports several practical recommendations for reducing the risk of BPH and slowing its progression. Base the diet on vegetables, fruits, legumes, whole grains, nuts, and seeds. Consume cruciferous vegetables and dark leafy greens regularly. Include tomatoes and cooked tomato products as frequent sources of lycopene. Replace much of the red meat in the diet with legumes and other minimally processed plant proteins. Include moderate amounts of oily fish if following an omnivorous diet. Use extra virgin olive oil as the principal culinary fat. Maintain a healthy body weight through appropriate energy intake and regular physical activity. Minimize refined carbohydrates, sugar-sweetened beverages, and ultra-processed foods. Avoid smoking and maintain good control of diabetes, hypertension, and dyslipidemia. Seek prompt medical assessment for persistent urinary symptoms. Conclusion: benign prostatic hyperplasia is no longer viewed simply as an inevitable consequence of aging or hormonal change. A growing body of evidence demonstrates that chronic inflammation, oxidative stress, metabolic dysfunction, and cellular senescence are central to its development and progression. Diet cannot completely prevent BPH, nor can it reverse established anatomical enlargement. Nevertheless, nutrition profoundly influences many of the biological processes that determine how rapidly the disease develops and how severely symptoms progress. The strongest evidence does not support any single superfood or miracle supplement. Instead, it consistently favors an overall anti-inflammatory dietary pattern rich in vegetables, fruits, legumes, whole grains, nuts, seeds, and other minimally processed plant foods, together with regular physical activity, healthy body weight, and good metabolic health. For men already living with BPH, these lifestyle measures complement evidence-based medical therapies and may help improve urinary symptoms while reducing the risk of further progression. For younger men, they offer a practical and scientifically grounded strategy for promoting lifelong prostate health. Ultimately, the prostate reflects the health of the body as a whole. The same dietary and lifestyle choices that protect the heart, blood vessels, and brain also help create a healthier internal environment for the aging prostate. In this sense, caring for the prostate is not about treating a single organ, but about embracing a pattern of living that supports healthy aging throughout the body.